Now in this video, we will see what is upper bound, of any set S, and what is the lower bound of the set S, of any set S, where S is the subset of the your partial order set in consideration. S is any subset of the partial order set in consideration. So let me draw any Hasse diagram. Now let's consider my set S is AB. My set S is AB. When my set S is A and B, then what is the upper bound of S? What is the upper bound of S? Upper bound of S. I mean, you know what upper bound of S is. In one of the videos, I already covered that. We are revisiting it. So, what is upper bound of S when S is A and B? So, this is your A, this is your B. What is their common joint point? So, A is related to C. Just look at one step above A. So, A is related to C. Is this C a common point for A and B? Then B is also related to C. So, this is what joint point, sorry, not common point, joint point. So C comes at the joint point. So so C will be in your upper bound, and whatever is in the upward part to C, all of them will be in your upper bound. D, E, F, D, E, F. Okay, so this part is covered. Now from A there is only one step. From A there is only one uh, direction to the upward path. So that is covered for your upper 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 bound of S is C, D, E, and F. What about A, B, and J? If I take my S to B, let's say this was S1, then upper bound of S1 is this. Let's say S2 is A, B, and J. A, B, and J. Then what is the upper bound? What is the upper bound of S2? So A, B, and J. One step above, one step from A, you get to C. Okay. Now, does B related to C and J related to C or not? Yes, they are related to C. It means C is their first joint point. Now, including C, anything in the upward path from C, all of them will be in your upper bound of S2. C, D, E, F. This will be in your upper bound of S2. Now, look at B now. Because from A there is only one direction to the upper path, so that is covered now. Look at now B, means you don't have to go and check two steps above A, because that will be covered in the upper path of C only. Now let's look at B. Let's look at B now. What is one step above B? One is C, that is covered here. Other is H. Now we have to look if all the elements belongs to H or not. So A does not belong to H. So H cannot be your joint point. So leave it. So from B, all the direction in the upper path is covered. From J, you can only go to C or H in the first step. So this is the upper bound for S2 also. Let's take S3, which is B and J. S3 is B and J. Then what is the upper bound of S3? What is the upper bound of S? You go one step from B, you get to C and H. So first you get to C. So is C your joint point? So J is related to C also. So C is the first joint point. So C and everything from the upward direction to C, every node that comes in the upper path from C, D, E, and F, they all will be a part of our upper bound of S3. Okay, but B is also related to H. Means one step from B, you also have H, and J is also related to H now. It means H is also a joint point. So upper bound of S3 is CDEF union H and whatever comes in the upward path from H, G and F, G and F. So this is equal to C, D, E, F, H, G, F. Okay, let's take C and I. Let's take C and I. Then one step above I, if I take S4 to be, let me write it this side. Let's say S4 is C and I. Then C and I, one step above I is G. C is not related to G. So G is not the joint point. Similarly, one step above C is D. D is not related to, means I is not related to D. So D is also not the joint point. So we will go two step above C. Same is the case. E, I is not related to E. C, two step above C is F. I is not related to F. So they do not have any joint point. So upper bound of S4 is 5. Okay. Let's take S5, set 5 S5 to be C and H. Now upper bound of S5 will be H is not related to D. So D is not a joint point. H is not related to E. So E is not a joint point. H is related to F. So F can be a joint point. The procedure is simple. You go one step from C, you get to D. Now this D is not your joint point. Now you get to two steps from C, that is E here, and from H, H is not related to E. There is no upward path from H to E. So H E also cannot be a joint point. From H in your one step you go to one step in the upward direction you go to F. From C in two steps you go to F. And this is the first joint point. This is the joint point of C and H. So upper bound of S5 will contain F and everything that comes in the upward direction, as F is a maximal element. So upper bound will have only F. For C and H, the upper bound is F only. What is least upper bound? As the name suggests, this is least. You know what a least element is. Least element in the last video we have seen what a least element is. Least element in terms of the whole partial ordered set. Okay, in terms of the whole partial ordered set, we saw what a least element is. That is, uh, if no other element is related to that element, but this element is related to every element in your process. Similarly, this is least upper bound. Least upper bound means what? Means in your upper bound, these are the elements in your upper bounds. Among these elements, is there any least element? This is what it means. Okay, least element in your upper bound set, upper bound of S. So least upper bound of S is equal to least element in your upper bound of S. So if you look at least element, least upper bound of S1, the least upper bound of S1 is C, because C is the first join point. For A and B, C is the first join point, and this is a unique join point. Okay, this is a unique join point. So there is, this is your upper bound of A and B. This is your upper bound of A and B. So in among this set of elements, C is the lowest, C is the least element, because C is related to every element in that set. So least upper bound of S1 is C. Similarly, least upper bound of S2 is C, D, E, F. C, D, E, F. This is your upper bound of S2. So least upper bound of S2 is equal to C. We will look at least upper bound of S3 in a while, but now look at S4. Upper bound is 5. There is no element in the upper bound, so least upper bound does not exist. There is no question of least upper bound. So least upper bound of S4 is equal to 5. And there is only one element in your upper bound, and we know that F is related to F. We know that F is related to F because of reflexivity. So what is the least upper bound of S5? Least upper bound of S5 is equal to F. Okay. Now let's look at least upper bound of S3. Actually, least upper bound of S3, it do not exist. It is equal to do not exist. Why? Because as you can see, for S3, which is B and J, there is not a unique join point. So you have C as your join point. So everything from C in the upward direction, everything will come in your upper bound. But there is another H. H is also a join point. So everything from G, everything in the upward direction will come. If you just look at these elements, if you just look at these elements, there is no least element. C and H are minimal elements, right? So there is no least element. So how do you find a least element? If you set S, if you set S, if the elements of set S has a unique join point, then that join point is your least upper bound, and everything in the upward direction from your least upper bound, everything in the upward direction to the join will be a part of upper bound. Okay, so S1 has A and B has a unique join point, which is C, and these are your upper bound, and C is your least upper bound. S2, which is ABJ, they have a unique join point, which is C, and so everything that comes in the upward direction will be a part of your upper bound, and C is your least upper bound, because C is related to every other element in your upper bound. But when it comes to S3, you don't have a unique join point. You have two join points, C and H. So B and J, this C is also a join point, B and J, H is also a join point. In your upper bound, your join point is going to be a minimal. Means in the set of your upper bound, in this set, the join point is going to be a minimal element. So C is a minimal element in CDEF, and then you are applying union, and H is a minimal element of HGF. So totally, when you combine these two, you have two minimal elements. So that's it for today. In the next video, we will see we will see lower bounds and greatest lower bound. Thank you very much.